Okay, welcome back. In the last video, we took care of this turn-in-place mechanic where if we rotate greater than 90 degrees, we will turn smoothly and play a turn-in-place animation. So that way, if we're not running anywhere and we're just standing still, then we can actually turn instead of sliding her feet, which was what she was doing before. Now in this video, we're going to take care of this problem that we have where she is not pointing her gun in the correct direction where we are pointing our camera. And we're going to do that with an aim offset. Now an aim offset is a special type of asset that behaves very much like a blend space. If we go into our animations folder and we take a look at our blend space, for example, our running blend space, we'll see that we have the ability to blend between animations based on our offset yaw, which is basically the difference between where we're looking and where we're running. Well, we would like a blend space that would have her point in a particular direction based on where we're looking. And we can do that with an aim offset, which is basically a blend space, but the difference is that it's additive. It takes the pose of her pointing her gun in a particular direction and adds it on top of the animation that is her base pose. So let's create an aim offset. So here in the animations folder, right click and go to animation and choose aim offset, not 1D, but we want aim offset because this will be 2D. We're going to choose Bellica skeleton and we're going to give this aim offset a name. Let's call this hip aim offset. Now double click on this and you'll see that it looks a lot like a blend space. We have a horizontal axis, we have a vertical axis. Now the horizontal axis is going to be using the yaw based on our aim rotation where we're rotating our controller. So we're going to use the name for horizontal axis and we're going to give this the name yaw. We'll give the vertical axis the name pitch. Now for the horizontal axis, we're going to give this values from -180 to +180. And for the vertical axis, we'll give these values -90 to +90. And we'll see why shortly. Now, in the very middle, this is going to be the natural pose where she's looking straight forward. Now here in our asset browser, if we type AO, we'll see that we have a whole bunch of AO animations. Now, these are made for aim offsets. That's what AO stands for. Now, if you look at idle AOCC and double click on it, you'll see that it's just her natural pose. She's looking straight forward. And this CC stands for center, center. The next one after looks like she's looking down, and this CD stands for center down. The next one is idle AOCU, and CU stands for center up. So you can see that there's a naming convention here designed for an aim offset. Go ahead and close that and get back into hip aim offset. Now if I hold shift, then that green diamond will follow my cursor, and that allows us to preview the pose corresponding to those values of yaw and pitch. So in the asset browser, search for AO once again, and we're going to take this idle AOCC and drag it into the very center. And now you'll see that the idle AO center center is in the middle, and she now has that pose. You'll also see that in additive settings, the preview base pose was set because these are additive animations and they're designed to be added onto a particular pose. And these idle AOCC and other associated AO animations are designed to have the base pose idle 0 pose. And so that is the base pose that they're adding the animations onto. Now let's take idle AOCD, which stands for center down, and place it down here at the very bottom. So idle AOCD is in the center on the down or the bottom row here. And if we hold shift and drag down, you'll see, I'll go ahead and zoom in on Bellica here. you'll see that she starts looking down as we hold shift and drag the mouse down towards the bottom here. And so this, you can start to see how these additive animations work. It's adding on to the base pose by having her rotate down. Now let's take idle AOCU, that stands for center up, and put it all the way up at the top in the center here. And we'll hold shift and drag the mouse cursor up, and you'll see that she starts looking upward. So already you can start to see how this is going to change the way she's pointing the weapon this is based on pitch, because as we're moving upward in the pitch direction. Let's continue. Here, the next animation is idle AOLBC. Now double click on that and you'll see that she's looking all the way back to her left, and she's not looking up or down, but in the center. So left, back, center. So let's go back to hip aim offset. And this idle AOLBC needs to go to her left. Her yaw is going to be all the way looking back behind her. That's why we go back to -180, and it's in the center. So it's going to be back here all the way to the left, but in the middle. And if we hold shift and drag the mouse to the left, you'll see that she's slowly starting to turn and look behind her like this. Now the next one is idle AOLBD, and this stands for left, back, down. And you can see in the preview, she's looking all the way behind her, but also looking downward. So we're going to drag this all the way to the bottom left corner. And you'll see that as we drag to the left and go down, she's starting to point that gun down towards the ground. Now the next animation is idle AOLBU, which stands for left, back, up. So we can drag this to the upper left corner. And if we drag our mouse cursor while we hold shift, you'll see that she starts to look up. So you're starting to see the naming convention here. The next is idle AOLC. This is for left center. So there's a spot here between the middle and looking behind her. This is looking to her left by 90 degrees, and it's in the center, so it's not looking up or down. So we're going to put this here in the middle on the pitch axis, and just between the center and looking behind her, so she's looking to the left. And we'll drag this and see that she's looking all the way 90 degrees to the left, but not quite behind her. So she can look to the left and she can look behind her like that. The next one is idle AOLD, which stands for left down. That's going to be right here between the middle and -180 in the yaw direction, but it'll be all the way down at -90 in the pitch. So we're going to put it right there. And so you'll see that it's looking 90 degrees to the left and down. Next is idle AOLU, which will be up here. It'll be -90 in the yaw and +90 looking up. So we'll put that there. And there she's looking to the left and up. So next is idle AORBC, which stands for right, back, center. So that's going to go right here to +180 in the yaw and 0 in the pitch. Next is idle AORBD. That's going to be right, back, down. Next is idle AORBU. That's going to be right, back, up. And now you can see that she can look all the way to the right and up or down. Scrolling down, we have idle AORC, which is to the right and center. That's 90 degrees to the right and in the middle. Next, we have idle AORD. That's right, down, 90 to the right and -90 in the pitch. Next is idle AORU, that's 90 to the right and 90 up. And we have the next one is RMB, and that stands for right mouse button. That's when we're aiming our weapon. So those are going to be for a aiming offset. That's why we call this aim offset hip aim offset. So this is the creation of the aim offset. And now you can see how these additive animations allow us to have different pitch and yaw values. And as yaw and pitch changes, she's pointing her weapon in a different direction. So we can go ahead and save that, and we can close out of it. Now let's go to our shooter NMBP and just really quickly look at how this works. Now, if we search the asset browser for hip aim offset, we'll have this hip aim offset. We can drag it in here, and it's a node, and it takes a pose, and it takes an alpha, a yaw, and a pitch. Now we have the yaw. We have this root yaw offset. So if we type root yaw offset, we'll get root yaw offset. And remember, root yaw offset is a measurement of how much we're aiming relative to the forward direction of the character. And it's also got the negative sign of our rotation. So we need to drag off of this, multiply by a float, and the float we're multiplying by is -1. And if we multiply root yaw offset by -1 and plug that into the yaw, then if we take our cached rotated root bone pose and plug it in and plug the output of this into the output pose, then if we compile and press play, we'll see now that if we rotate, she's rotating her weapon. The only problem we have is that we're not changing the pitch. We're not plugging anything into that pitch node. I'm going to hit escape and you'll see that we have the pitch node here in the hip aim offset. We're not plugging anything into that, so pitch is staying 0. So we can get the pitch and store that as a variable in our Shooter Anim instance. Let's go back to Visual Studio. So we're here in Shooter Anim instance, and I'm going to add another variable for the aiming pitch. So down here at the bottom, I'm going to add a float, and I'm going to call this pitch, and I'll give this a U property so we can access it in the editor. So we're going to make it visible anywhere, blueprint read only, and I'll give it the category turn in place. Now we need to set this, and we're going to go to shooteranimInstance.cpp, and we're going to set this. So let's go down to turn in place, and we want to set this pitch whether we're running or not. We still want our pitch to be accurate even if we're moving or if we're staying still. So just under this check to see if shooter character is null, we can set the pitch. So I'm going to say pitch is equal to shooter character, and we're going to call the function getBaseAimRotation. GetBaseAimRotation returns a rotator, and we can get the pitch component of that, and we're going to use that to set our pitch. So the base aim rotation gives us a rotator corresponding to where we're aiming. Now this is based on the controller. This basically gives us the rotation corresponding to the crosshairs that we have on our screen. So getting the pitch of that is accurate for what we would want for an aim offset. Go ahead and compile this. So back here in Shooter Anim BP, since we've created the pitch variable and exposed it to blueprints, we can get pitch, and we can simply plug this in as the pitch for the hip aim offset. So compile this and go ahead and press play, and now you'll see that she looks down and she looks up as we rotate our controller and thus our camera up and down. So now she can look all around, and she can also fire as she's looking all around in different directions. Now we can reload and we can turn as we're reloading. Now notice though, when she reloads, it's sort of screwing around with the clip placement. And so when we reload, we'd like for her to sort of go back to looking forward while she's reloading, and then go back to where we're looking when she's done reloading. So we can do that. So back here in shooteranimInstance.h, I'd like to add a boolean for when we're reloading. So let's call this bool b reloading. Now this is going to be visible anywhere, blueprint read only. We do need to access it from our blueprint. So I'm going to copy the pitch U property, and I'll go ahead and give these both some comments here. So for pitch, the comment will say the pitch of the aim rotation used for aim offset. And for B reloading, our comment will say true when reloading, used to prevent aim offset while reloading. Now let's give pitch and B reloading default values in Shooter Anim instance. So we'll go up here and we'll say that pitch by default can have a 0 value, and B reloading by default can be false. And now we need to set that, and we're going to set B reloading here in turn in place. Now we want B reloading to be true if we're reloading, false if we're not, and so we'll set that right here. But how do we know if we're reloading or not? Well, we know that shooter character.h has this enum called combat state, and when we're reloading, the character is in the reloading state. So why don't we go ahead and create a public getter for the combat state variable on the character. So we'll come back down here to the bottom and we'll say force inline, and we'll call this get combat state. It's going to be a const, and it's going to return eCombat state. That's the type it will return. So eCombat state, get combat state. It's going to be a const, and we're going to simply return combat state. So a standard getter for our enum combat state. So we can use that. Now back in shooter anim instance.cpp, here in turn in place, we can simply set be reloading. In fact, we don't really even need to put this in turn in place. We can set this in update animation properties up in here. So here inside our check to shooter character, why don't we just put it here instead? So we're going to say be reloading is equal to shooter character, and we can simply say get combat state is equal to eCombat state and reloading. So be reloading is equal to this Boolean expression. We're using the comparison of shooter character get combat state is equal to eCombat state reloading. So if that's true, be reloading will be true. If this is false, be reloading will be false. So we can go ahead and compile this. Okay, so we're here in the shooter anim BP, and what we'd like to do is prevent this hip aim offset from being active when we're reloading. And we can use a blend poses by bool node for that. Blend poses by bool allows us to use one pose if a Boolean is true and another pose if a Boolean is false. So we're going to right click and type blend poses by bool. And we'll right click and type get reloading, and now we have this Boolean called reloading. That's our C++ Boolean be reloading. Now for the true pose, this will be the regular use cached pose, cache rotated root bone, because that is the pose without the aim offset. So we can disconnect these and we'll use cached rotated root bone for when reloading is true. When we're not reloading, then we can use the hip aim offset. So I'm going to copy cached rotated root bone, paste it here, put it into hip aim offset, and use that for the false pose. So we're using the hip aim offset when reloading is false. So plug that in and compile, and let's give this a test. Okay, so we are not reloading and the aim offset is working. Now I'm going to look up somewhere like this so it's obvious we're using the aim offset, and I'm going to hit R to reload. And she goes back to her regular pose to reload, and then she looks back up when she's done. So that's exactly what we wanted. So now we won't have that funky clip hovering problem. We'll get her to reload the clip as normal and then go back to her aim offset pose. So that looks great. Now, another thing that I'm noticing is we can reload at any time. So if we hit the R key, we could reload, and it doesn't matter if we already have a full gun. And we shouldn't really be able to reload if we have a full gun. We're going to prevent her from being able to reload if the gun has ammo. So let's go back into Visual Studio. And in shooter character.cpp, let's go to reload weapon. Now here we're checking to see if we're carrying ammo of the correct type, and then we play the anim instance. But we should also check to see that we're not at max ammo capacity. Now it'd be convenient if we had a function on our weapon that would return true or false if we're carrying the maximum amount of bullets. In other words, if the clip is full. So let's go to weapon.h and let's add a public function that will return a Boolean. So this will be bool clip is full. So this will be a function that will return true if the amount of ammo is equal to the maximum capacity of the magazine. And that variable was an integer that we created called magazine capacity. So we're going to compare ammo and magazine capacity. Okay, let's give this new function a function body. And for clip is full, we want to make sure that ammo is less than the magazine capacity. So we're just simply going to return ammo is greater than or equal to magazine capacity. So in shooterCharacter.cpp, we check to see if we're carrying ammo, and we're also checking to see if the clip is not full. So we're going to use not and equipped weapon clip is full. So this way we won't reload if the clip is full. Now one more thing we want to fix is when we're rotating, notice that the hand doesn't look quite right. It doesn't stay on the weapon. Now this has to do with the order that things are done in the anim graph. Now take a look in our shooter animBP anim graph. Now we have our blend poses by bool, and we're using our hip anim offset. Okay, and this blend poses by bool is taking the result from the rotated root bone. But the truth is we want to rotate the root bone after we do the hip aim offset, because rotating the root bone is causing things to get out of whack. So here's what we're going to do is we're going to first use our hip aim offset and do our blend poses by bool, and then we're going to rotate the root bone after that. So here's what we can do is instead of using cached rotated root bone, we can use cached hip to aim, which goes into the rotate root bone. So we're going to use that instead, and that's going to go into blend poses by bool, and it's also going to be what we put into the hip aim offset. So we don't need to use those. We can use cached hip to aim here. So this is essentially using the hip aim offset and the blend poses by bool without using the rotate root bone. We're going to do the rotate root bone after that. So why don't we take all this stuff, copy it, and we'll make a new state machine, and this will be the aim offsets state machine. Right click just under hip to aim, type state machine, and let's make a new state machine and call this aim offsets. And double click aim offsets, drag off of entry, add a state and call this aim offsets. Double click this, and we're going to Control V to paste our use of blend poses by bool and the hip aim offset here. Now connect this to the output pose. Now back in the anim graph, we're going to take our aim offsets and cache this. And we're going to call this cached aim offsets. And now we have the aim offsets. We can feed that into the rotate root bone. So we're going to use cached aim offsets and feed that into rotate root bone. That way we're rotating the root bone last, and we can delete these things that we copied and pasted into the aim offset state machine, and instead we can simply use the cached rotated root bone. So cached rotated root bone will go into the final output pose. And now if we compile and test this, we'll see that our hand stays relatively on the gun. Now it does deviate a little bit off of the gun, and that's actually something you can see in the aim offset itself. The aim offset isn't going to be perfect. Now there is something we can do later to keep the hand exactly on the gun and keep it from deviating. But this actually looks a lot better, and we can fire, and you'll see that her shoulder does get that recoil thanks to our blending that we've done earlier with the weapon fire animation. So that is going to take care of the problem of keeping the hand on the weapon during the aim space. And again, if we reload, she goes back to the regular idle pose where she's looking straight forward. And this can easily be seen if we look up, doing a dramatic pitch angle, and hit R to reload. We'll have to fire first. There she goes back, and then she looks back up. Okay, so this will conclude this video. In the next videos, we will continue implementing these behaviors, so stay tuned.